bonds with other elements. Like everything you see, salt, everything is a mixture of, not a mixture, my bad, a chemical formation between two different atom elements. And I'll be telling you why they bond or form this new compound. So each element, oh, by the way, we talked about last time, we talked about, this is sodium. Last time we talked about how many electrons each element has and why it has that much. So we remember from last time that sodium has 7 electrons in its outer shell, and if we do the same for fluoride, we'll see that fluoride has 7 electrons in its most outer shell. And in group 8, all the elements have full outer shell, so they do not have any valence electrons, so they do not have any leftover electrons. That's why these elements do not react with anything. Group 8 elements are unreactive. They do not react with any other elements. So elements react so that they can get outer shell. Every element wants to be like these noble gases, we call them. This group 8 is called noble gases. They all want to be like the noble gases and have a full outer shell. And in order to get a full outer shell, they have to create bonds. And the first type of bond we'll be talking about is an ionic bond. An ionic bond is a bond between a metal and a non-metal, and sodium is a metal, and fluoride is a non-metal. So what happens is sodium needs to lose an electron, because think about it, gaining 7 electrons versus losing 1 electron, what seems easier? Losing 1 electron. So what sodium tries to do is lose an electron. So we'll be drawing not all 3 of its outer shells, but we're only going to be drawing 2 of its outer shells, alright? So don't get confused. We're only going to draw 2 of its outer shells. So sodium, as we remember, the second outer shell can hold 8 electrons. So we should change the color to red. The sodium has 8 electrons in its second shell. And that's 8, and 1 electron in its most outer shell. And it tries to lose this one. This is the electron it will try to lose. And on the other side we have fluoride, or fluorine, I mean. But once it creates a bond, it's called sodium fluoride, and I'll be getting into the names later. We have fluoride, which has only 2 electronic shells, but I'm only going to be drawing the last one. So here we are with fluoride, and its last outer shell. I'll be using a different color for that. We'll use green. It has 1, 2, 3, 4, 5, 6, and 7. So it's missing an electron, and sodium needs to lose an electron. So I think we all know what will happen in the end. Sodium loses the electron, and once sodium loses an electron, it has more protons than it has electrons. So as you remember that we learned last time, the number of protons in each element is the same as the number of electrons. So sodium now has 10 electrons because it just lost 1 electrons, but it has 11 protons. And you remember what we talked about last time, that protons and electrons have a charge. Protons have a positive charge and electrons have a negative charge. So now sodium's overall charge becomes positive. So it becomes positive because it has Na+, and its outer shell now becomes the shell with the 8 electrons. This shell then disappears because it has lost an electron. So there's no point of a shell being there if it does not hold any electrons. So now we have 8 electrons here. And what happens to this electron? Well, it gets in here. So then fluoride, oops, fluoride now. So fluoride is happy because fluoride has its full outer shell. There we are. And it's one electron. In this case, it's the one electron gotten from sodium. And now this has a full outer shell, and this has a full outer shell. But the thing, another thing is that fluoride now has more electrons than it has protons, and we know that fluoride has 2 electronic shells because it's in period 2. So it has 2 plus 8, so it has 10 electrons, 10 electrons and 9 protons. 9 protons. So fluoride's overall charge becomes negative. And in chemistry, negative and positive forces attract. So these two attract and they become one. And well, yeah, they become sodium fluoride. Sodium. Sorry. Sodium. Sorry about that. Fluoride. And this is a perfect case of bonding, but there might be, for example, if it was a element from group 2, then they would require 2 fluorides and one of this, because this would lose 2 electrons, and fluoride can't get 2 electrons because then it won't have an outer shell, so it'll get 2 fluorides. But yeah, this is what the ionic bond looks like, and in the next video we'll be talking about covalent bond, which is different.